Okay, so welcome back to another physical sciences lecture. We are on page, let's see what page, we're on page 21, motion graphs. Oh, I don't like black. Let me change my color. I don't want it to be black. So motion graphs. And in this course, we limit our analysis of motion graphs to motion in a straight line. So just the two directions. And the table below is a summary of the relevant information we can obtain from each graph type. So it's important when you're working with graphs is you understand which graph you're actually looking at. So if we have a displacement versus time graph, so remember S, so this is actually meters versus time in seconds. And again, meters here and seconds here. We can get the direct reading of what the displacement is for a given time, but we can also calculate the velocity from the gradient, because if you remember, gradient is equal to rise over run, and the rise will be the displacement, so that will be the rise, and see how that's in meters. So the rise will be in meters, and the run along the x-axis, so displacement goes up and time goes across, meters divided by seconds. So see how meters divided by seconds, that's the same unit as meters per second. So that's what velocity is. So if you're working in displacement versus time, you can work out the velocity from the gradient. Now, if we look at velocity, this is meters per second and time again seconds. So again, meters per second here and seconds here. So if we look at the rise over run this time, it's equal to meters per second over seconds. And so that's equal to meters per second squared. So the gradient will give us our acceleration. Okay, so if we have a displacement versus time, velocity versus time graph, we're given meters per second up here and seconds here. So imagine you had some sort of velocity for a given time, and this made like a rectangle like that. Okay, so if you were to calculate the area, so the area of the area under the curve, so between the curve and the axis, we can find that out by doing length times width. Okay, so if we say length is meters per second times width, which is seconds, that's equal to meters, which is our unit of displacement. Okay, so calculating the area between the curve and the axis will give us meters. So finally, so that's velocity versus time graphs. So finally, acceleration versus time. We're not going to worry about the gradient. So if we've got these grayed out areas, it's because we're not worrying about, say, the area under the displacement versus time curve. So we don't need to worry about that, and we don't need to worry about the gradient on an acceleration versus time graph. But similar to up here, if we have an acceleration, so meters per second squared times by seconds, so the area under there will be meters per second squared, times by seconds, which is equal to meters per second. So that's why it gives us our meters per second velocity there. Okay, so we'll look at some examples in the next video.